Briefly, in this video, we're going to talk about the concept of equality and identity. Let's get started. An equality is a mathematical expression in which two quantities have the same value. For example, 5 plus 1 equals 6. Here we have an equality, since the value of the left side is the same as the value of the right side of our equality symbol. Right? So is this an equality? Let me put another one here. I'm going to separate with a semicolon. For example, if we have 8 minus 4, this is the same, for example, as 2 plus 2. Here as well, this is an equality. Again, why? Because the value of what's on the left side is the same as what's on the right side. So, are these equalities? And when we only have numbers, it's pretty simple, right? But what happens, for example, if we have letters? That is, if we have variables or unknowns. Well, in this case, we could have either an equation or an identity. And it's very important that you know how to tell the difference. Look, let me write equation over here, and I'll write identity over here. It's very important that you know how to distinguish an equation from an equality, because even though they seem similar in concept, they're actually quite different things. Look, I'm going to write an equation here for you. For example, 2x plus 3 equals 7. This is an equation. Now I'm going to write an identity, for example. 2x plus x, 3x equals 3x. See how they look very similar, right? Because both have the equal sign and both have letters. But the main difference lies in the following. Look, in the equation, we will see that it will only be true for a certain value or certain values of the letter. That is, in this case, the unknown. Whereas the identity will hold true regardless of what value we assign to the letter. What do I mean by that? Look, if I say, for example, that x is equal to 4, I want you to see that this will not hold true. Why won't it hold true? Well, because if I put a 4 in, I would get 2 times 4. That's 8 plus 3. I don't get 7, 8 plus 3 is 11. I'm not getting 7. Therefore, it's not holding true. Let's see. And what would happen? For example, if x equals 2. Let's see. Let's check. If x equals 2, I get 2, 4 plus 3. Yes, that's 7. So, when x is 2, is this equality holding true? So, since it only holds true for certain values of x, does that mean that what we have here is an equation? Now, what happens, again, with the identity? In the identity, no matter what value you put in, it will always hold true. Look, for example, what happens if x is equal to 4, just to use the same numbers? But can I put in any number I want? Here I get 2 times 4, 8 plus 4, that's 12. And on the right side, we also have 3 times 4, which is also 12. So, when x is equal to 4, it works. And what happens, for example, if x is equal to, let's say, 0? We had said that also with 2, right? Let me change it here. Sorry. So what happens? If x is equal to 2, then I get 2 times 2. 4 plus 2. That's 6. 6 is on the left side, and on the right side, we have 3 times 2, which is 6. So when x is equal to 2, it also works. And I could keep going like that, right? For example, for x equal to 0, on the left side, I would have 0 plus 0, which is 0, and on the right side, I also get 0. Therefore, it also works. So you can already see the difference, right? In the equation, just remember, the equality will only hold for a certain value or certain values of x or whatever letter we have. And in this case, it will hold regardless of the value, plugging into the unknown, or, in this case, the variable. So you can see if you really understood me, I invite you to reflect a little with the following questions I'm going to ask you, which will revolve around these 4 points. How can you tell? Well, here we have 4 equalities, right? So, pay attention to the questions and start thinking about the answers. The first question is, which one or which ones are algebraic equalities? I insist, which one or which ones are algebraic equalities? Keep thinking about that. Very well. The answer is that numbers 1, 2, and 4 are algebraic equalities. This one right here is not an algebraic equality, simply because we don't have any letters, right? I mean, we don't have variables, but it is still an equality, right? Look, here we have 5 plus 9, which gives me 14. And here we have 4 squared, which is 16 minus 2, which also gives me 14. So, this one here is an equality, but it's not an algebraic equality. So, let me just remove it right now, so it doesn't confuse us. Now, out of these 3 that are left, I ask you, which one is an equation? Or, well, which ones are equations? Because it could be that more than one is an equation, right? Start thinking about that. Which one or which ones are equations? Very good. The answer is that number 4 is an equation. And how do I know that number 4 is an equation and these 2 are not? Well, that's what we're going to talk about. Look, this is an equation for the simple reason that if I put any value for x, this won't necessarily be true. That is, I could put something simple, for example, a 0. Look, if I set x to be 0, the equality won't hold. Let's see if that's true. So I would have 2 multiplying. Pay attention. I'm going to substitute a 0 here. Okay, in the 4. Here. So, it would be 2 times 3 times 0. But 3 times 0 is 0, so I'm not going to write it. And here, I only have minus 4 left. And on the right side, we have 5 times 0, right? Plus 8. That would give me 0 plus 8, which in total is 8. Let's see, and I ask you, is 2 times minus 4 equal to 8? No, right? This gives minus 8. So, minus 8 is not equal to 8. As you can see then, when x is 0, the equality is not being satisfied. This means then that this equality will only be satisfied for a certain value or certain values of x. In this case, it will only be satisfied for a single value of x. Okay, so it doesn't hold for just any value. This means that now the equation, so now, I'm going to erase this. How do I do it? How can I know if these 2 are identities? Because are these 2 actually identities? What do I do to make sure I'm right? I'm sure that in fact, it's about identifying. So here it goes. We actually have 2 different methods. I really like the first method. The first method consists of assigning values to our letters, to our variables. For example, for part A, I can say that A equals 3B equals 2 and C equals 5. It really doesn't matter what values we assign. It always has to hold true, regardless of the values we choose. So, let's go ahead and substitute. So here I would have A, which I'm saying is 3, multiplying B, which I'm saying is 2, plus C, which is 5. And well, on the right side, we have A times B. So, in this case, it would be 3 times 2 plus A times C. In this case, it would be 3 times 5. All right. Now, let's do the operations on both sides, and we should get the same result here. So I have 3 times the sum of 2 and 5, which is 7. And on the right side, we have 3 times 2, which is 6, plus 3 times 5, which is 15. On the left side, we have 3 times 7, which is 21. And on the right side, we have 6 plus 15, which is also 21. As you can see, for these values that we're making up, the equality does hold. And if we change the value of A, B, or C, or all of them, in any way, it will always hold true. So does that mean that what I have here, this equality is really not an equation, it's an identity, because it holds for any values I can put in? That would be method number 1 then. Method number 2 is actually a little simpler, and this one simply consists of working out what I have here. That is, I could directly do a times B, which gives me AB here, plus a times C, which gives me AC. And well, if I end up with the same thing as what I have here, then it means that it is, in fact, an identity. So this is indeed an identity, as you can see, quite simple, right? Now what happens, for example, with exercise, well, with part number 3. In the case of part number 3, I want you to see that, again, I told you this was an identity, but let's check it again. First, with the first method. For example, I want x to be 2 and y to be, let's say, 6. Okay, so here we go. I'm already making things complicated for myself, right? Well, it doesn't matter. So, let's go ahead and substitute. I would have x, which is 2, plus y, which is 6, and we raise it to the power of 2. It should be the same as x squared, so in this case, 2 squared plus 2 times x times y, which is 2 times 2 times 6, plus y squared, which is 6 squared. It should give us the same result, right? Okay. Regardless of what values we're using, 2 plus 6 is 8. So here, I would have 8 squared. On the right side, we have 2 squared, which is 4 plus 2 times 2. That's 4, and 4 times 6 is 24, and plus 6 squared, which is 36. 8 squared is 64, and on the right side, we have 4 plus 24 plus 36. Let's see. 36 plus 24 is easy. That's 60 plus 4 is 64. So, as you can see, for these values that I picked completely at random, it does work. And again, I can keep changing the values, and it will still work. I encourage you to try with different values, and you'll see that indeed, the equality will always hold. So, since it will always hold, that means it's an identity. So this would be the first method. Now, the second method, as we said, is simply to expand. So, let's expand x plus y squared. You'll agree with me that it's the same as x plus y times x plus y. So, let's go ahead. X times x equals x squared. Then plus x times y equals xy. Then plus y times x equals yx, which is the same as xy. And finally, e times e equals e squared. All right, so this would be equal to x squared plus xy plus xy. Since they're like terms, I can add them, so it would be 2xi, and this y squared, we'll just write it down. As you can see, we're arriving exactly at this. Does that mean this is an algebraic identity then? Well, that's all for today. I hope the video was helpful, but most of all, that you enjoyed it. If you liked it, please subscribe to the channel. I'm uploading videos every day. Also, I invite you to check out this complete playlist, since here I'm putting together the Mathematical Thinking 2 course for high school. See you next time. Take care and behave yourselves. Bye-bye.